Now, as NASA's Artemis II hurtles back to Earth for a highly anticipated splashdown off the coast of San Diego, the world is watching a historic moment unfold. The mission has already rewritten the record books, with the Orion spacecraft surpassing the distance milestone since last set by Apollo 13, a remarkable leap in human space exploration. But we've got some questions. What happens next when the astronauts return home, from recovery operations at sea to post-mission analysis, and the physical and the psychological readjustment of the crew? This moment marks not just the end of a journey, but the beginning of a new phase in deep-sea exploration. Now, the key achievements of the Artemis II, what this mission means for humanity's return to the moon, and how it sets the stage for future lunar landings and even missions to Mars, is what we're going to be unpacking very shortly. And to discuss the mission, we are joined by renowned astronomer David Block. David, thank you so much for your time this evening. I think we've pretty much said it all in the introduction.
Yes.
A seminal moment. The splashdown is a source of such great excitement and anticipation. If you could just help us review the mission so far, those pivotal moments of the flight, and essentially what NASA's looking for or looking to do in the post-mission analysis.
Yes.
Yeah.
I think that we have to unpack this very carefully. The first moon landing was, of course, Apollo 11, which was in 1969. I was 15 years old, listening on a little transistor radio in Krugersdorp. And, of course, that's 1969, and now it's 2026. Now, imagine us testing an autopilot now compared to testing primitive autopilots and computers in 1969. And so the whole raison d'etre of this mission has really been to test the latest modular equipment and AI guidance, because Neil Armstrong, I remember this very well, had to manually control the rocket from time to time. AI is now so sophisticated. Now, what's the aim behind all of this?
Tell us.
The aim behind all of this is to set up a station on the moon near the South Pole, and I can explain why near the South Pole. You've got water there, not a lot of water, but you've also got some sunlight, and it's just a perfect condition as a base, a stepping stone.
Sure. And just unpack that further for me. I'll get into the particularities of the LEM system, right? Setting up that initial, I guess, what would be the building blocks of that full-time stand. But for the skeptics who are wondering, just how do we benefit from this, right? You've spoken about the fact that this flight is proving the utility of contemporary technology. But why this interest in the moon specifically? For the kids who in the back who didn't hear it the first time.
I love that question. And the point is, men and women, boys and girls, are born to explore. We're born, it's an adventure within us. We have a passion to discover key answers to key questions. We feel we're like, are we alone? Where do we belong in the universe? Are there other sentient beings like ourselves? And ever since the dawn of astronomy, and going back to Copernicus and Galileo, there's this driving urge within us to answer these fundamental questions.
That driving urge does cost a lot of money. So in terms of scientific leaps or advancements, what are the kinds of, I guess, experiments or observations that are going to be made there once, of course, the next Artemis crew goes up in what? In the
2030s.
In 2030s, exactly.
I would say about 2030s.
Yeah.
But the point is, a huge number of medical advances have come as a result of, for example, astronauts going to the International Space Station.
Sure.
So there have been a tremendous number of experiments, scientific experiments, specifically in the medical field. And a lot of medical advances can trace their roots back to very sophisticated computer technology. And that's the sort of technology, we have now on board the International Space Station. So I like to think of Neil Armstrong's words, Rafil, that's one small step for man, one giant leap for mankind. In other words, our knowledge is to finding answers to key questions, even medical ones.
Sure.
Many of them are solidified, as it were, in space.
Yeah. That next Artemis crew that we spoke about, so the next mission, Artemis IV, next
Yes.
mission set for about 2028.
Yes.
And when that crew reaches their landing site
Yes.
near the moon's south
Yes.
pole, which you mentioned, they'll be carrying a cutting-edge seismometer package,
Yes.
which is called the Lunar Environment
Right.
Monitoring Station. Why have a LEMS up on the moon? What is that? What answers is that going to demystify for us? Or
I
questions,
think
rather?
that one of the key, there are two answers really there. Firstly, the lunar base enables us to establish as a stepping stone to go to Mars. This is terribly important. But secondly, we want to find out how God created our universe. We want to understand the beginnings of space and of time. Now, there's something very important here. There are many observations which cannot be conducted from the Earth. Firstly, you've got our atmosphere. The moon has got no atmosphere. Sure. But why the far side of the moon, people ask me? Why not the near side? Well, the Earth is abuzz with radio waves. I mean, just think of it, TV and AI and whatever you want to think about.
Sure.
There's just the Earth is very noisy from a radio point of view. And the face of the moon, which we see, is also very noisy because it's pointing towards the Earth. So you don't want to do that. But the whole idea of establishing a base on the far side of the moon is that you can start probing radio wavelengths at around 10 megahertz. That means for the boy and girl in the street, the wavelength is about 1 to 10 meters. So that is impossible. Those observations are impossible. So we want from Earth, and we'd like to be able to go right back in redshifts, not to 12 or 13, but to well over 1,000. In other words, to probe what we call the cosmic dark ages. And interestingly enough, we don't have to go terribly far, like to Mars or Jupiter or to Saturn. We can answer many of these key questions, many of them, by simply observing on the moon. Now, you mentioned LEM, you mentioned seismic activity.
Very quickly, yes.
This is the whole dream, is how did our moon actually come to be? How active is our moon? What sort of material lies deeply embedded within the moon? Are there lunar quakes? If so, of what magnitude? Do you remember this, we've only been there for, say, a few days at a time in the Apollo missions, Apollo 11 through 17 and then excluding Apollo 13. So we've got questions regarding content, seismic content, regarding geology of the moon. These are questions which can only really be answered, specifically the seismic ones, if we actually go there. It's just like if we have a vast earthquake on Earth. Sure. The only way of establishing its intensity on the Richter scale is to actually set down equipment, but not equipment which lasts for, say, 3 days of the visit on a permanent basis. So you've got seismic experiments, and then you've got these wonderful experiments to explore the very dark ages, the beginnings of our Big Bang, which God used to create the universe. It's just, I, as a professor of astronomy, am so amazed at the advancement of technology in this regard. I never thought that we'd have lunar modules and, permanent bases on the moon.
Well, you certainly never thought that whilst you're listening to the first moon landing on a transistor radio.
That's how, I remember. It was so frustrating, but people in the United States could follow Apollo 11, and there I was in Krugersdorp holding this tiny little transistor radio, if you were, to my ear.
Yeah.
And that's how I learned it all. But it's been, the lunar explorations have been absolutely wonderful. And when man landed on the moon in 1969, former President Mandela was on Robben Island. And so NASA had a dream to actually show him a piece of the moon, a piece of moon rock, which had been collected by the Apollo astronauts. And I just was so privileged to be able to take it to his home in Houghton and show him. And I'll never forget his words. He was just so enamored that he was actually holding a piece of history in his hands. And I think that's what this whole mission speaks about. And a splashdown tonight, a little later, we can discuss.
Well, we unfortunately do have to say goodbye. We are out of time. But thank you so much for bringing the story alive for us and just contextualizing it and, of course, bringing it closer to us, making it feel immediate that whatever's being done up there, whatever happens up there and the developments do actually impact us, and it's a shared gain by humanity,
Absolutely.
Not just a few countries. We really do thank you for your time. Thank you so much. And of course, that was Professor David Block, who is a renowned astronomer, talking to us, of course, about that Artemis mission.